This is the 6th video on the chapter about essential ideas in chemistry. This subtopic is going to be about significant figures, also called sigfigs. The reason we care about sigfigs is because we want to make sure that we only report the number of digits that we have actually measured and are sure about. For example, if you were going to weigh an item on the scale and it weighed 103 pounds, then you definitely measured the 1, the 0, and the 3. But if you stood on a different scale, that scale might have measured it to say 103.2. And so that one is more significant than the other one. We're more accurate digits than the other one. So we need to have rules about whether each of these digits in a number is significant. So the first rule is that all non-zero digits are significant. So all the other numbers, 1 through 9, those numbers are always significant no matter where they are in the number. What we do have to worry about is zeros. There are a few cases where zeros don't count as significant figures. So zeros are significant, except for these two cases. So case number 1 is called a leading zero. And case number 2 is a certain type of terminal zero. Make that plural. Terminal zeros with no decimal point in the number. Okay, let me give you an example that we can use. So here's a number 0.00120500. Lots of numbers to work with in that one. So when we're trying to count the number of significant figures in a number, the first thing we want to count is the significant figures for the non-zero digits. So we've got 1 is significant, 2 is significant, and 5 is significant. Then we want to check the zeros. So we're looking for discounting these two types. So we're going to discount a leading zero. Leading zero means that it comes before the first non-zero digit. Okay, so the first non-zero digit in this number is the 1. And so all the numbers that come before the 1 don't count. So this 0 doesn't count, this 0 doesn't count, and neither does that one. Okay, so we've eliminated the leading zeros. And the other thing we're looking for is terminal zeros and numbers with no decimal points. And terminal means at the end of the number. So this number does have a decimal point, so we don't have any of those. So that means that this 0, which is in the center of the number, is significant, and these two terminal zeros at the end of the number are significant because the number has a decimal point. So 1, 2, 3, 4, 5, 6. This number has 6 significant figures. Okay, so we can give an example of something where this rule would apply, terminal zero with no decimal point, if we had the number 500, for example. So this number has terminal zeros. These two zeros are at the end of the number, but the number doesn't have a decimal point. So if there are zeros at the end and the number doesn't have a decimal point, that means that those terminal zeros are not significant. 5 is a non-zero number, so that is significant. So there is one sig fig in this number. And the reason we try not to write numbers like this is so that we know that the person did it on purpose and not on accident. So let's do a couple more examples down here to see how you're doing. And feel free to pause the video and do them first if you'd like to try them, and then check them with this video. So count the number of significant figures. So we're going to count non-zero digits. then we're going to count zeros in the middle of the number and zeros at the end of the number as long as there's a decimal point, and then we'll ignore leading zeros. So in this case, we've got 102, the 1 counts and the 2 counts. The 0 is in the center of the number, so that one is going to count. This number has 3 significant figures. All right, moving on to the next one. We'll count the 1, we'll count the 7. The 0 is a terminal 0, but there is a decimal point in the number, so that's significant. And then we don't count anything in this bit. This is just part of the scientific notation. So these numbers are not important. So we have 1, 2, 3 significant figures in this number as well. All right, down here we've got 0.01. So the 1 is significant because it's not 0. And then these 2 zeros are leading zeros. They come before the first non-zero digit. So we are not going to count those because we didn't actually measure that number. The only number we actually measured was the 1. There's 1 significant figure in this one. And 1 is the smallest number of significant figures you can have. You can never have 0. And then down here in part D, 760, the 7 is significant, the 6 is significant, and this is a terminal 0, but there is no decimal point in the number. And if there is no decimal point, we can't be sure that terminal 0 is significant, so we don't count it. There are 2 sig figs in this number. There is one exception to this terminal 0 situation that I want to include here. And that is when you're measuring an exact number. And what I mean by an exact number is something that can't have a fraction of it. Like if you were counting people, you can't have 2.3 people. You can have 2 people or 3 people, but you can't have a decimal or a fractional amount of people. So that means that exact numbers have unlimited sig figs. They have as many as you need them to have. For example, if you were counting people, or if you were counting eggs, you can't have a part of an egg. So, but just to be clear, when you're measuring an exact number, it's best to put a decimal at the end so that that 0 is counted as a significant figure. Okay, so these are all the rules you need to know for counting significant figures in a number. And now we're going to get into the difficult stuff, which is what happens when you have to do math with a number. So there are rules for carrying significant figures during calculations. Because if you measured a number yourself, you can be very certain as to how many significant figures it has because you were the one working the scale. But if you're adding 2 numbers together, you need to make sure that that number that you get as a product or as a sum or as a difference or as a quotient has approximately the same number of significant figures as the numbers that you started with. You don't want to multiply 3.7 times 2.9 and get a number with 17 digits in it. That's not accurate. So there's 3 rules for when you are carrying numbers around during math. So rounding. So if you need to round it up and eliminate some of the numbers from the end of the number, you were going to take numbers between 1 and 4 and round down. If the last number is between 6 and 9, you'll round up. And if you have a 5 at the end, you'll round to the nearest even number. Oops, there we go. The next rule is about addition and subtraction. Okay, when you are adding numbers together, you are going to keep the fewest number of significant figures after the decimal point. And that has to do with how we line numbers up when we're adding them together. So remember that bit about the decimal point, that's unique to addition and subtraction. And then we've got a rule for multiplication and division. Okay, and the rule for this is we keep fewest number of sig figs, period, regardless of the decimal point. Okay, so what we're going to do is we're going to work math problems and find the accurate answer. Then to make our answer precise, we're going to go back and check and use these rules to decide how many significant figures to keep. And if we have to drop some of the digits off the end, we'll use this rounding rule to tell us how many to get rid of. So this all looks very well and good on paper, but we need to try it ourselves to see if this actually makes sense. So I've got a couple of example problems here. Feel free to do them on your own before watching me do them in the video. We're going to compute the answer for each problem, and then we're going to go back and round the answer to the correct number of significant figures. All right, so we're going back to middle school here, doing some add, subtract, and some long multiplication. So the first one is about adding these two numbers together, 13.5 and 14.60. So I always find the accurate answer, the correct answer first, and I round it after I found it. So I'm just going to add this up the long way since I've got it written out. Brings me back to those good old days in elementary school. Okay, so my first answer that I reached is 28.180. So that's going to be the correct answer. And then I want to round that to the correct number of significant figures. So I'm going to put an arrow here indicating that I'm going to round it. And then I'm going to check my rules. So this is addition, and the addition rule says we keep the fewest number of sig figs after the decimal point. So my first number, I've got a 5 after the decimal point, and that one is significant. So there's one significant figure after the decimal point. And my second number, I've got a 6, which is significant, an 8, which is significant, and a terminal 0 with a decimal, which is significant after the decimal point. So that's 3 sig figs after the decimal point. And the rule says that I should keep the fewest number of sig figs after. So that would be a 1. So that means I'm going to cut my number after the first digit after the decimal point. So then I need to round it. So I look at the number immediately after the cutoff. And if this is an 8, that means I'm going to round the number before it up. So I'm going to round it to 28.2. And that number is going to have one significant figure after the decimal point and 3 significant figures total. So it feels like we did an awful lot of work for just adding two numbers together that we could have done in about 5 seconds on a calculator. But we need to understand that if we weren't very confident about all the digits in this number, then we can't possibly be this confident in the answer when we add them together. All right, let's try the next one. So this one is a multiplication, 2.35 times 7. So I can just go ahead and do this one the long way. Beautiful, very nice. Okay, so the first answer I've got is 16.45, and I need to figure out how to round that answer appropriately. So I'll check my rules. We're doing a multiplication step. So we're in the answer, we're going to keep the fewest number of sig figs from the numbers that were multiplied together. So this number had a 2, which is significant, a 3, which is significant, and a 5, which is significant. So it had 3 sig figs. And my second number was 7. That one only had 1 sig fig. So I'm going to keep the smallest number, which is the 1. So that means I have to round 16.45 to 1 sig fig. So the number after the rounding spot is a 6. So that means we're going to round it up. And be careful, we're not rounding it up to 2 because this is in the 10th place. We need something in the ones place. We're rounding it up to 20. So 16 is either rounded down to 10 or up to 20 to have 1 sig fig. And this is one of those like slightly confusing numbers where there isn't a decimal listed, and it's kind of difficult to remember if that 0 is arbitrary or not. So the most accurate way to write something like this would be to write it in scientific notation. Write it as 2 times 10 to the first. So that way, we don't have to include this 0 to indicate that it's 20 and not 2. We can just put it in the scientific notation and show that there is just 1 significant figure here. Okay, so there's our answer, and it has 1 significant figure. All right, now it is time for our monster problem here. Sometimes we have to add, subtract, multiply, and divide at the same time. We're not just doing one step at a time. So let's practice doing something a little bit more challenging. We're going to approach it exactly the same way as we did before. We're going to find the answer by just doing the math first. Then we're going to go back and do the problem again, counting our number of significant figures. Okay, so let's add together 14.7 and 56.35 to give us the numerator. 71.05 says my calculator. And then we'll do the bottom one. 8.4 times 27.853. That gives me 233.9652. So then if I take 71.05 divided by 233.9652, and I'll show you what I did here. I didn't want to type in this number all over again. So instead of typing in this really long number, I used the answer, which is here above the negative sign. Second answer uses the previous answer, so you don't have to type it in. That gave me 0.3036776409. And it probably continues, but the graphing calculator will only give you 10 digits. Okay, so this is the accurate and correct answer, but it feels ridiculous to write down a 10-digit answer when I only had 3 or 4 or 5 significant figures in the numbers that I started with. So what we're going to do is we're going to go back and do the math again, but we're going to round after each step. So the first step we did was an addition and subtraction. And in addition and subtraction, we count the number of sig figs after the decimal. So this number has got 1 after the decimal, and this number has got 2 sig figs after the decimal, and the smallest is 1. So that means we need to round the answer to just this addition part to 1 after the decimal. So that means we would round it to 71.1. We would cut it right here, and we would round up. Okay. And then the second thing we did was this multiplication on the bottom. Multiplication means you count all of the sig figs and take the smallest. So we've got an 8 and a 4, 2 sig figs. This one has got 2, 7, 8, 5, and 3. 5 sig figs. And we want our answer to have the smallest of the 2, which was 2. So for our denominator, we're going to round that to 2 sig figs. So we're going to round it right here. And the 3 is going to round down. We're going to have 230 with no decimal. Or we could write 2.3 times 10 to the second to be more exact. All right, so now we have the last thing we did was to divide. Dividing is the same rule as multiplying. So this number had 3 sig figs. Number on the bottom, remember it only had 2. That 0 was a trailing 0 with no decimal. 2 sig figs. And we're going to keep the smallest number of sig figs for the answer, which was 2. So that means we round our answer to 2 sig figs. So we're going to, this one's not significant. We're going to keep the 3 and we're going to keep the 0. And then 3 is going to round down. So 0.30, or we can write that as 3.0 times 10 to the negative first. So I just want to take one last minute to point out why we didn't do this the first time. If we added these together and we rounded that number, we multiplied these and we rounded that number, what would happen if we divided these two numbers, 71.1 over 230? So for that answer, we would get 0.309, blah, blah, blah. And if we wanted to round that number to 2 sig figs, that doesn't count, that does count, that does count. We would cut it here, but this time we have a 9 afterwards, and the 9 would cause us to round up, and we would round our answer to 0.31 or 3.1 times 10 to the negative first. And we know that this isn't the correct answer. This number up here is the correct answer with lots and lots and lots of numbers off of the end. If we round to the significant figures too early, then our answer becomes inaccurate. And as we do more and more steps, this inaccuracy gets even bigger. So this is why I recommend calculating the number all the way through to the end, carrying all the significant figures first, finding the correct answer, and then rounding it to the correct number of sig figs after you finish. This one is an incorrect answer that you get by rounding first. So we always want to compute the answer first, then go back and figure out how many significant figures the answer would have and round it appropriately, rather than rounding as we go. Rounding as we go creates extra errors. And that is the end of the chapter on essential ideas in chemistry.